Welcome to The Explainer. Today, we are unpacking a seriously paradigm-shifting tool for Java developers. If you're out there architecting high-frequency, mission-critical, or low-latency real-time applications, well, the way you think about your user interface is about to fundamentally change. We're diving deep into the Web Firm Framework, or wffweb for short, and looking at how it completely re-engineers the bridge between your backend server and your user's browser. So here is the high-stakes question we really need to start with today. How exactly do you build a real-time trading application or a highly secure banking dashboard without paying the latency tax of traditional client-side frameworks? When literally every millisecond means money, the standard way we've been doing things might actually be your biggest bottleneck.
Okay, let's jump right into our first topic, the real-time web challenge.
In a normal web application setup, you typically have your Java backend communicating with some client-side JavaScript UI framework. Now, this means handling constant HTTP requests, AJAX calls, and usually relying on intermediate servers to funnel that data to the client. Think about it. If you want to show a livestock chart using a standard client-side UI framework, you actually need an intermediate server just to communicate with the broker's WebSocket server. That intermediate jump, it slows down data delivery to the client. It creates friction. And in high-throughput development, friction equals latency. We simply can't afford that.
Which brings us right to our solution. Enter Web Firm Framework.
Now, what actually is wffweb? Well, it's a Java presentation framework, but actually scratch that. It's not just another templating engine. It lets you dynamically generate and update HTML5 and CSS3 entirely from your server, using pure object-oriented Java. There are literally no separate HTML or CSS files required here. You are writing your entire UI as Java code. And you can really see what this is built for when you look at the use cases. The documentation specifically targets developers building complex, high-stakes interfaces. We're talking banking products, mission-critical UIs, and heavily data-driven real-time applications like trading dashboards. This is huge, especially if you're building for the Indian market. SEBI compliance rules actually mandate a static IP for placing algorithmic orders by April 1st, 2026, to secure and trace everything. With wffweb, you can make stock market API calls directly from your Java app using your server's registered static IP. If you're using a standard client-side framework, you just can't do those direct, secure calls. It's a total game changer. Let's shift gears a bit and look at how this is built for ultimate speed. So, where does this massive speed actually come from? First off, zero disk I/O. Because the complete web page is dynamically generated by logical Java programs right in memory, it bypasses the need for disk reads entirely. Second, it operates as a true single-page application where only the absolutely required portions of the page get updated. The CPU and memory consumption on the client side is minimal because all the heavy lifting is happening on the server. But the real magic? That's in the communication protocol. Bypassing standard HTTP means you eliminate DNS lookups and the constant opening and closing of connections on every single request. By using bidirectional, full duplex WebSockets, your Java code can actually directly subscribe to a broker's WebSocket server. Then, your server just pushes UI changes straight to the browser, the exact instant a stock price tick changes. It really is the absolute best option for low-latency, high-throughput app development.
Next up, we really need to talk about the server-side security advantage.
Here's how this architecture just inherently solves security. Because your UI logic is kept exclusively on the server side, malicious users literally can't tamper with your client-side JavaScript logic, mostly because there isn't any. You control the exact state of the UI from the absolute safety of your Java backend. It's fully locked down. And when you combine that server-side logic with secure WebSockets, or WSS, you get an incredibly fortified application. As the documentation points out, this drastically reduces the risk of man-in-the-middle attacks. It makes it a highly compelling choice for banking and trading platforms where data integrity is absolutely non-negotiable.
Moving right along to Section 5, Lossless Network Reliability.
So version 12 introduced this absolutely critical feature called lossless browser page communication. Just imagine this scenario. Your server pushes 3 UI updates, but the user's network drops exactly during update 2. Update 3 then becomes invalid, right? Because it relies on a state that the browser just never received. Instead of breaking the UI, or even worse, showing corrupted data, wffweb detects that missing payload, gracefully ignores the invalid step 3, and automatically triggers a page reload to resync with the server's absolute truth. You never show the user bad data, ever.
So why are Java experts actually choosing this over the alternatives?
The crucial point is that this empowers Java experts to own the entire stack. You can write your whole UI in Java or Kotlin. It features powerful server-side URL routing, giving you single-page app performance without the heavy client-side JavaScript tax. Plus, it's highly thread-safe, and features like shared tag content let developers update multiple tags across the UI from one single point in the backend code.
And despite packing all this power, it is astonishingly lean. It doesn't rely on bloated Java EE classes at all. Its memory consumption is so low that you can run highly complex real-time UIs on low-memory servers or even embedded containers. It's just incredibly efficient.
Which brings us to our final thought for today. We've explored how WebFirm Framework uses direct WebSockets and purely server-side UI generation to deliver uncompromised speed and SEB-ready security for high-frequency trading. So if you're building platforms where milliseconds, static IPs, and absolute data integrity matter, you really have to ask yourself, is your current client-side UI framework actually holding your high-performance Java backend back? Thank you so much for joining me on this explainer, and I highly encourage you to dive into the WebFirm Framework documentation to see this architecture in action for yourself.